Hello guys, welcome to my channel. This is Vidya Mugi. Today we'll be learning on quantity estimation of manhole. So as you can see in this video, I have shown you the different components and different sides of the manholes. So firstly, this is the plan, what you can see here. This is the plan. So this is the length of the manhole, this is the width of the manhole, since the main pipe is running parallel to the bigger length. So I'll take this as the length and this as a width. So end to end size you can see here, it is 120 plus 60, 180 centimeter, and this is 90 centimeter. Since all the dimensions are given in centimeter, so I'll be discussing in centimeter, but ultimately we'll be writing them in terms of meters. Right, then if you see at the section taken here along the main pipe, so the section along the main pipe is like this. That is, when you stand here and if you look at the manhole, so you'll get this scenario. Similarly, if I take a section along the width, so this is how the manhole looks, right? So manhole is, this is the road level, this is the road level. So below road level, this is the component of the manhole, right? Then quickly moving on to the quantities. The first quantity is earthwork in excavation. Earthwork in excavation. So we'll have a look of how we got these dimensions. So one thing is, you have to first check for the plan to find out the dimensions. As I have already told, that the width of the excavation or length of the excavation and width of the excavation will be same as that of the PCC bed. Now you have to look what is the length of the PCC bed and width of PCC bed. Now in this case it is very simple, because if you have a look at the two different sections that are shown, if you see the section along AB, you will get what? The length of the excavation, which is same as that of PCC bed. So it is given as 280 centimeters. Then the width of the excavation, which is along section EF, which is given as 190 centimeters. So the length of excavation is what? 2.8 meters, that is 280 centimeters, and width is 190 centimeters or 1.9 meters. Now we'll have a look at how the height is 2.9 meters or 290 centimeters. We'll start from the top. So this is the road level. So from road level till what depth we have went for excavation. So this thickness, what you see here, the filling that is done, is nothing but it is the depth of 10 centimeter. That 10 centimeter how you will get, you see here. This is the 10 centimeter which is shown here. So this thickness is 10 centimeter. So coming here again, so this is 10 centimeter, we got to know from this section. So this is 10 centimeter, this is 70. So 10 plus 70 is how much? 80. 80 plus, so from this top to this edge it is given as 100. So 80 plus from here to here it is 100. So 180. 180 plus 90. 180 plus 90 is how much? 180 plus 90 is 270. 180 plus 90 is 270. 270 plus thickness of this bed concrete is 20. So 270 plus 20 is 290. So 290 centimeter, or it is taken as 2.9 meters. So multiply this, you will get what is the quantity of excavation, which is in meter cube. So we got our first quantity, earthwork in excavation. Moving on to the next quantity, that is cement concrete. Cement concrete 1:3:6 with brick ballast. So in this cement concrete, we have to calculate the concreting for foundation and bed and benching. Right. Firstly, I'll discuss foundation and bed. Now, as I said, cement concrete components and excavation components are same, because your width or your volume of excavation what you carry out for earthwork, the parameters used for calculating volumes will be same for the cement concrete. So like that, for foundation and bed, that is this foundation bed, the length will be what? Length of bed concrete will be 2.8, as we have seen here it is 2.8. Width will be 1.9, that we have seen here it is 1.9, but only difference here will be what? The thickness. The thickness here will be 0.2, that is the thickness of the bed concrete that you have provided. It is given as 20 centimeters, which is nothing but 0.2 meters. Next, talking about benching. Now benching is done inside the manhole. So that is where the pipe passes through the RCC component. So this is the manhole and this is the sewage pipe that is passing within the manhole. So this part of the manhole should be done benching so that the pipe is not damaged. So the purpose of doing the benching is so that the pipe, when under pressure, should not fail from any external components, right? And since manhole is accessible, so benching is done to provide stability to the pipe, also to safeguard it from any breakage. Now if you see from the section of EF, that is this part, so this is what is called as the benching. They have done a concreting here and they have placed the pipe in between, right? Now this benching is required for what length and for what width? So benching is required for only this part of the pipe is within the manhole. So only this part of the pipe requires benching, right? Rest, this is covered with the bricks, this is covered with the bricks, and rest it is underground. So length of benching is what? 120 plus 60. So how much is that? 180. So 180 is nothing but 1.8 meters. What is width of benching? It is 90 centimeters. So I'll write this as 0.9. Then what is the height? So height is nothing but the out to out diameter of the pipe, which is 40 centimeter, which is given here, or I'll write it as 0.4. So you got what is the cement concrete required for foundation and bed and benching. So find out the total quantity, and the total quantity works out to be 1.7 meter cube. Now this 1.7 meter cube we have to go for deduction. Now deduction is upper portion of main channel and upper portion of branch channel. Why deduction? Because when we calculated the cement concrete, we did not consider the amount of cement concrete that is to be reduced at this portion. When we calculated, it was 1.8 meter length complete and 0.9 meter width and 0.4 depth, which means we calculated it as like this, which means we calculated it as a rectangular component like this. So this is the total cement concrete that is going to be laid. Inside this we are going to provide pipe like this. Means this is the extra quantity that is generated, right? But we require only this part. Right? But when we calculated it for complete. So that is 1.8 meter length, 0.9 meter width and 0.4 depth. Now to eliminate that extra quantity which is at the top as well as this pipe occupied by the pipe, but to reduce this much amount of volume occupied by the pipe and this upper portion. Now for that we'll take up deduction part, which is the upper portion of the main channel and upper portion of the branch channel. Now upper portion of the main channel, so length will be remaining same, it is 1.8. so pipe is running full, you can see here this is running full. Now difference here will be what? You have to take the width as the average of 0.9 width and the in dimensions of the pipe, and that you have to divide by 2, that is this portion. So width is 0.9, 90 centimeter, 90 that is 0.9 plus 0.38 divided by 2, that is the lump sum quantity that they have calculated, because it will be very difficult for you to draw a straight line here, calculate what is the area of this triangle, what is the area of this rectangle, so which will not be properly acquired because this is going circular like this, so you cannot get a proper rectangle here, right? So to avoid all those calculations, what we have done is we have taken the average of this total into in width plus into in diameter of the pipe, 0.9 plus 0.38, that is divided by 2 is what is the width of deduction that we have taken, which is the net deduction. So 1.8 length, hope you are clear with this. 0.9 plus 0.38 divided by 2 will be the width, and this depth is this depth. So we have assumed that 0.4, right? So total quantity calculated was what? 0.4, which was this part. Total quantity calculated was 0.4. Now we have taken that depth of deduction as average, which is 0.15. So that is the depth of deduction that we are going to carry out. So this 0.15 is nothing but this arch what you see here. This arch what you see here, there is called as relieving arch, which is nothing but it is 10 centimeter thick. So this relieving arch is 10 centimeter thick, which is provided over the pipe. So that 10 centimeter plus some extra quantity which is added to that, so that overall deduction is taken as 0.15. So overall your total deduction quantity is 1.8 into average of this value plus 0.15 depth. So I said already 10 centimeter is the relieving arch plus 5 centimeter is added, so 15 centimeter. So 0.15 is the depth. So quantity for deduction for the upper portion of the main channel is 0.17. Similarly, we will carry out for deduction of upper portion of the branch channel. So upper portion of the branch channel, you can see here. So the length is taken as 0.3. So 0.3 is nothing but it is deduction over this this length, which you can see here, reduction over this length, which is 0.3 meters. So length of that is 30 centimeters. So this is 30 centimeter. So 0.3 is the length. So 0.3 is the length. Width is same as the diameter of the pipe, 0.2, and again the depth is taken as 0.15, which is nothing but it is the depth of relieving arch. So we'll keep the same depth of deduction for both. So doing that, you will get the total quantity of deduction for pipes, which is 0.18. So from total quantity of cement concrete, you deduct this deduction volume, you will get the total quantity of deduction, that is 1.53. Right? Okay. So next, moving on to first class brickwork in 1:4 cement mortar. This is the third quantity. So since I have discussed with you people that whenever you are calculating the brickwork quantity, we follow the long wall short wall approach. Right? We follow the long wall short wall approach. Okay, so next quantity I was discussing was about first class brickwork. Now if you see here from this figure, the component of walls are divided in 3 steps. From the bottommost part, it is, I'll take this as first step, second and third. So purple line indicates it is 40 centimeter thick, pink line indicates it is 30 centimeter, and black line indicates it is 20 centimeter. If you look from the plan, this purple line is the 40 centimeter thick wall over which a 30 centimeter wall is resting, so that the inside face of the wall is in the same line. Right? So the variation is with respect to the outer face. So 40 centimeter wall, 30 centimeter wall and 20 centimeter wall. So 20 centimeter wall is rested over 30, 30 is rested over 40. Now when you calculate the quantity for 40 centimeter wall, so how that will be? So if you take only the 40 centimeter wall like this, right? So it will be rectangular component like this in the plan. So what I'll do is I'll divide this in terms of the long walls and short walls. Now which are the long walls? I'll consider this as the long walls now. Right? So when I consider these are long walls, this internal length is 180 and this length is 90 centimeter. So this is 180 and this is 90. Right? Now if I want to know what is the out to out dimensions, means I have already calculated the volume up till here. If I calculate the quantity of this one wall, and if I multiply by 2, I'll get what? I'll get the quantity of two sides. Then what is remaining? The remaining portion is this. So which is nothing but it is the short wall, right? Now what is the length of long wall? What is the length of long wall now? 180 plus 40 on this side, 40 on this side. So this will be what? 180 plus 40 plus 40. So 40 is 80 plus 180. It is 260. So you'll get this as 260 centimeters. So there are two such walls. What is the short wall? It is 90 centimeters. Similarly, you are supposed to do for 30 centimeter wall. So 30 centimeter wall will be what? 180 is into in plus 30 plus 30. So 180 plus 60 is 240. Then for 20 centimeter it will be what? 180 plus 20 plus 20. So this will be 220. And what will be the short wall for all the cases? It will be 90 centimeters, right? Because we are considering the horizontal lengths. Now in that same pattern, what I'll do is I'll take long walls for first step, second step and third step. So how many long walls for first step? Again look at this figure. So long wall for first step is what? 40 centimeters. There are two long walls for 40, two long walls for 30, two long walls for 20. Similarly, two short walls for 40, two short walls for 30, two short walls for 20, right? So with that, so we calculated the length of long wall. Now it was 260 centimeter, 240 centimeter, and okay, so I'll come to this later. So 260 is 2.6 meters, 2.4 meters. So width of 40 centimeter wall was 0.4, 0.3, and height, we'll look here. 40 centimeter wall height is 90 centimeter, 30 centimeter wall height is 100 centimeter, right? So it is 0.9 and 1 meter. So we got this quantity. And as I was saying here, 20 centimeter wall is resting over 30 centimeter wall. So what I did was I considered this as it was resting over throughout, but 20 centimeter wall is cut at this portion only. It is only provided up till this portion. Then they have provided a RCC slab here. They have provided a RCC slab. So your 20 centimeter wall is only up till this length. It is only running from this length to this length, right? So that is the reason why he has given you the two portions here. See here. So this is 20 centimeter wall. The dotted line what you see is 20 centimeter wall. You can see here. I thought it was from here to here, so I took it as complete length, but no. The case is different here. So they have provided a RCC slab and 20 centimeter wall is running from here to here. So what is the length of 20 centimeter wall now? It is like this. I'll show you. This is not right. So 20 centimeter wall is running like this. It is only this small part, and this is 20 centimeter thick. So in dimensions of this is what? So after that we have RCC slab here. This portion, right? This portion is RCC slab. It is like this. Look from the plan, if you look from the side, it is like this. So this is the slab portion. So our wall portion is only this. So end to end dimension is 60 centimeters. You can see here. This is 60 centimeter, 20 and 20. So now this, if I have to divide this into long wall and short wall, what I'll do is I'll join these lengths. So this is 60 plus 20 plus 20. 60 plus 40 is how much? Or 60 plus 20 plus 20 is 100 centimeter. And again this is 0.9. So that is the reason why it is 1 centimeter here, 1 meter, 100 centimeter or 1 meter. So we have two such walls. So thickness is 0.2 and height is, as you can see here, it is 70 centimeters. So it is 0.7. So we got the quantity for long wall. Similarly for short walls, first step. So width will remain same for all three. So thickness same as this and height same as this. So you'll get the quantity of short wall. Add all this, you'll get the total quantity of first class brickwork. I hope you are following the things. So I think you understood the things what I discussed related to the manhole now. Any doubts, please feel free to ask in the comment box. Thank you. The next part will be the remaining quantities that I'll be taking in the second part. Thank you. Thank you very much.